Hello everyone, welcome to Easy Physics again. Today we are going to look at the resistors in AC circuits. Again we will use reasoning in our teaching. The objective for today's lesson is that after this lesson you are going to be able to describe the process occurring in AC circuits containing resistance. So what is a resistor in a circuit? Here is a real resistor and this is its symbol. When we connect a resistor to a circuit, here is the resistor, the flow of the current is prevented by the existence of the resistor. I mean, when you increase the resistance of the resistor, the current in the circuit will decrease. The relationship is described by the Ohm's law. When you increase the resistance, the current in the circuit decreases. So simply, the resistor is a component that resists current. So how does an AC circuit behave when there is a resistor? If we have an alternating current source and we have connected a resistor to this source, as you see, the source and the resistor are parallel each other. The current is going to flow through the resistor, and the voltage, there is going to be a voltage drop across the resistor, which is we will define it VR, and the voltage of the source is a changing source, alternating source. The voltage drop across the resistor will also change. Here is the change of the voltage of the source, and also since they are parallel to each other, the change of the voltage of the resistor is also going to be a function like this. So it will have a peak value, it will have a zero value, minimum value, zero value, again peak value. So the voltage here and the voltage drop across the resistor are parallel to each other. They are going to be maximum at the same time, zero at the same time, minimum at the same time, and zero at the same time, maximum again same time. The change of the voltage is a cosine function. It is equal to E0 cosine WT. This E0 is the Emax, maximum value of the voltage. And sometimes we show it with E0, sometimes Emax, sometimes we will show it with EV. So what is the current in this circuit? Current from Ohm's law is equal to VR over R, and we already know that the voltage is changing with the time. It is a cosine function and it is equal to VR cosine WT, and if we divide it to R, we will get IR cosine WT. I mean, this is the current. So as you see, the voltage is changing with the time and the current is also changing with the time. Their functions are completely the same, cosine WT, cosine WT. Here, VR over R, I mean this value is the peak current. IR is the peak current in this formula. So what is the change of the voltage and current in an AC circuit when there is only one resistor? So as I told, these are parallel to each other. The voltage and the resistor are parallel to each other. When the voltage of the source is maximum, the voltage of the resistor is also maximum. So the formula for the change of the voltage in the circuit is VR cosine WT. The change of the current in the circuit is IR cosine WT. As you see, this is cosine WT and this is also cosine WT. Only VR and IR are different from each other. So the functions are going to be completely the same, just their peak values are different from each other. Here they are going to be the maximum at the same time. When the current is maximum, voltage is also maximum. So they are going to be zero at the same time. They are going to be the minimum, but at different values at the same time, zero at the same time, maximum at the same time. So briefly, we say that voltage and current are in phase in an AC circuit. This is the first question, and we are asked to find the peak value, frequency, period, and instantaneous value of current at t is equal to 0.5. T is equal to 5 milliseconds. Here is the change of the current with the time. Okay, so let's look at the peak value of the current. The general formula for the current is equal to I is equal to I max cosine WT. And this is our current in the circuit. I is given as 38 cosine 320 t. the peak value, as you see, these two correspond to each other. I peak or IR or I, let's call it I0, its peak value, or I maximum. Here we have written I maximum, so it will be 38 amperes. And then what is the frequency in this case? We know that frequency is equal to W over 2 pi. What is W in this equation? As you see, here is the T, they correspond to each other, and these two corresponds to each other. It means W is equal to 320, so it will be 320 divided by 2 pi, and it will be equal to approximately 51 hertz. Next, what is the period? T is equal to 1 over F, and it will be 1 over 51. It will be approximately 0.02 seconds. And finally, the instantaneous value of current at t is equal to 5 milliseconds. Current at t is equal to 5 milliseconds will be equal to 38 is the maximum value. I'm going to use this formula, 38 cosine 320 times the 5 milliseconds is 5 times 10 to the negative 3 seconds. So calculating this equation will give us approximately 38 amperes. Okay, let's go to the next question. Write down the equation for an alternating current voltage of 50 hertz and peak value of 30 volts, and also draw the corresponding voltage versus time graph. And we know that the change of voltage with the time will be equal to V is equal to V max, or let's write V0 cosine WT. And let's first find W. It is equal to 2 pi F, and it will be 2 pi times 50 will be equal to 100 pi is the W. So from here now we can write our equation as V0 is given 30, is here, and cosine 100 pi t is the equation. So let's look at the corresponding voltage versus time graph. The voltage is going to change with the time. So this is one cycle, and we need to know the period for this cycle. This is voltage, by the way, and this is the time. We already know the maximum value. It is 30, and this is also negative 30. Let's find the period for this cycle. We know that t is equal to 1 over f equals 1 over 50, and it is 0.02 seconds, which is equal to 20 milliseconds. So here is one full cycle is 20 milliseconds. So half cycle is 10 milliseconds, and this will be 5 milliseconds, and this is going to be 15 milliseconds. The time is in milliseconds. Okay, let's look at the next question. An AC circuit carries an RMS current of 8 amperes. The current travels through a 15 ohm resistor. What is the peak value of the current? And the RMS current and RMS voltage was explained in our previous videos. Now we are going to continue with the solution of the question. So what is the peak value of the current? The peak value of the current I0 is equal to square root of 2 I RMS, and it will be square root of 2 times 8, and it will yield approximately 11.3 amperes. So what is the peak voltage drop across the resistor? The peak value of the voltage, I mean V0 or V max, will be equal to square root of 2 times V RMS. But first we need to calculate the V RMS, and we know that V RMS is equal to I RMS times resistor. I'm going to use the Ohm's law here. I RMS is given, it is 8, and the resistor is 15. It will be equal to 120 volts. So now let's go back here. V0, the peak value of the voltage, will be square root of 2 times 120, and it will be approximately 120 volts. The next question is, a 40 ohm resistor is connected across the electromotive force, I mean the voltage source. The function is given like this. Write an expression for the current through the resistor. And then what is the current at t is equal to 60 milliseconds? The current I will be equal to V over R. And the voltage is given as 180 times cosine 120 pi t. Divided by the resistor is 40 ohms. And then this will give us 180 divided by 40 will be 4.5 times cosine 120 pi t. So this is the expression for the current through the resistor. By the way, this is the maximum value of the current. So then what is the current at t is equal to 60 milliseconds? The current I t is equal to 60 milliseconds. So this current will be equal to 4.5 cosine 120 pi times 60 milliseconds is 0.06 second. Okay, if we calculate all these mathematical expressions, we will get 3.64 amperes. Actually, negative 3.64 amperes. It means since the current is changing like this, okay, these are positive values and these are negative values. It will correspond a value somewhere here or somewhere here or somewhere here, somewhere here. So it is smaller than the maximum value. As you see, the maximum value of the current here is negative 4.5 and here it is 4.5, and the current will change between these two values. And the last question is, what are the peak voltage across each resistor? The instantaneous resistor voltage at t is equal to 10 milliseconds. Here we have a alternating current source, we have two resistors, and we are asked to find the peak voltage here and peak voltage here. Also we are asked to find the instantaneous voltage at t is equal to 10 milliseconds. So for this, first we need to find the R equivalent is equal to 5 times 20 equals 25 ohm is the total resistance. So let's find the value of the, since we are going for A, we need to find the peak value, peak voltages. That's why first we need to know the peak current. Peak current will be equal to, I mean I0 or I max is going to be equal to, this is the peak voltage, it will be 200 divided by the total resistance is 25, so the peak current will be equal to 8 amperes. So if this is the peak current, we can now find the peak voltages here and here, I mean in this one and in that one. We know that V peak is equal to I peak value times resistor. For the first one, for this one, V will be, let's write V5 is equal to, it will be I maximum is 8 and R is 5, so the maximum voltage here will be 40 volts. Let's call this one V20. It will be equal to 8 times 20 and it will be 160 volts. So this is A. For B, the instantaneous resistor voltage at t is equal to 10 milliseconds. We know that, I will be equal to V over R, and this is the voltage change. The voltage change is 200 cosine 2 pi 60 hertz times t divided by R, and it is, the total R is 25. So from here, the change of the current in the circuit will be 200 divided by 25 will be equal to 8 times cosine 2 pi 60t. This is the change of the current with the time. So we are asked to find the instantaneous current at t is equal to 10 milliseconds. Instead of t, if we write 10 milliseconds, I am not going to write all the equation from the beginning. Just if we insert 0.01 here, it will give a value of negative 6.47 amperes. This is the instantaneous current in the circuit. So if this is the current, now we can find the instantaneous voltages. Again, let's say V5 will be equal to negative 0.47 amperes times the resistor is 5. It will give us negative 35 voltages. And V20, these are the instantaneous values, it will be equal to negative 647 times 20, so the result is 129.4 volts. So that's it for today. Thank you for listening. See you in the next lesson.